Welcome to section 6.6. In section 6.6, we'll be looking at systems of linear inequalities. Before we begin, let's do a quick warm-up and review graphing regular inequalities. Graph the inequality y is less than 2x minus 8. Let's see how you did. In this one, it's already has the y by itself, so we would go ahead and graph our y-intercept, which is a negative 8. From there, we go up 2 and over 1, and since it's less than, we shade underneath the line. So your graph should look something like this. Our vocabulary word for the day is boundary, and the way we're going to be looking here is a boundary is something that divides one item from another. So in the math usage, the graph of a linear inequality in two variables is a region bounded by a line. All points on one side of the boundary line are solutions. So, first thing we're going to be doing today is figuring out whether the ordered pair is a solution to the given system. So just like when we did this with inequalities, we are going to substitute in the 0 for x, the 1 for y. Now in this case, since it's a system, it has to work in both equations. If it doesn't work in one of the equations, it's not going to be a solution to the system. So for this one, if I substitute in the 0 for x in the first inequality and the 1 for y in the first inequality, I get 1 is greater than or equal to 3. That is not a true statement. So since it's not a solution to this inequality, it's not going to be a solution to the system. It has to work in both equations. So we don't even need to bother trying the second one. In this one, we're going to go ahead and do negative 2, 3, negative 2 for x, 3 for y. So we substitute that into the first equation, and it gives us negative 4 plus 9 is greater than 2. Well, 5 is greater than 2. That's true. So then we go on and try the second equation. So when we do that, we substitute in the negative 2 for x again, the 3 for y. This time we get negative 6 plus 15 is greater than 1. 9 is greater than 1, so this one is a solution. Second thing we'll be doing today is graphing linear inequalities, and there are 4 steps to graphing a linear inequality. The first step is to graph each inequality on the same coordinate grid, keeping in mind that if your inequality is greater than or less than without being underlined, you use the dotted line. Again, keeping in mind, you shade above the line if it's greater than or greater than or equal to, below the line for less than and less than or equal to. Then you do your shadings. The solution is the area where the shadings overlap. And then the last thing is to make sure you darken that area. So let's look at an example. Here they've graphed a system for us. You'll notice that there's 3 parts to the system. In this part here, the dotted line means that any point on the line is not going to be a solution to our system. This region here is the region where all of the solutions are, because that's the shaded area where they overlapped. And the third thing is the solid line means that those points on the line are solutions to our system. So you need to be able to make these graphs yourself. So let's take a look at an example of that. In this example, we have y is greater than or equal to a negative x plus 5, and we have negative 3x plus y is less than or equal to a negative 4. So the boundary line for y is greater than or equal to negative x plus 5 will be solid because it's underlined, and the boundary line for negative 3x plus y is less than or equal to a negative 4 would also be solid because it's underlined. Now we need to write the inequality in slope-intercept form, just like we did in the last section. So we need to get y all by itself. So when we do that, we have y is less than or equal to 3 times x minus 4. So now what we need to do is we need to graph the two inequalities. So we're going to come up to 5. We're going to put a dot, down 1 and over 1 since our slope's negative, and we're going to connect with our solid line. It's greater than, so we shade above. The second equation we're graphing is y is less than or equal to 3x minus 4. A dot on negative 4, up 3 and over 1. Connect your dots with a solid line, and it's less than, so you're shading underneath. The region where they intersect is this purple area, and that's the solution to this system. Let's try another one. Notice both of the equations already have y by itself, so we're just going to go ahead and graph the two inequalities and then shade. So when we graph the first inequality, we put a dot on 3, up 1 and over 1. Notice this time we used a dotted line because it's not underlined. The second one we have is up to positive 2 and then down 2 and over 1. Excuse me. This one would be a solid line because it is underlined. Shading underneath the first line because it's less than. Shading above the second line because it's greater than. Again, this purple area is our solution to the system. Let's take a look at another example. Keeping in mind that x equals and y equals are vertical and horizontal lines. So the first one is y is less than or equal to, so that's going to be a horizontal line. X is greater than or equal to a negative 2, so that's going to be a vertical line. So when we take a look at our graph for this one, we graph the line y equals 3, solid line because it's underlined, and we shade below it for less than. X is greater than a negative 2, so we have our vertical line at negative 2, and we shade to the right. So again, this purple area is the area where they intersect. Let's take a look at another one. Notice here the y's are not by themselves. So first thing we need to do is we need to get y's by itself. So in the first equation we need to subtract 3 from both sides. So we have y is less than 2x minus 3. The second one we need to subtract 3x from both sides. So we have y is less than negative 3x plus 5. Graphing these two inequalities, we have a dot on 5 and we went down 3 and over 1, connected with a dotted line because it's not underlined, shading underneath for less than. A dot on negative 3 up 2 and over 1, connecting with a dotted line again because it's not underlined, and shading underneath because it is less than. And again, the purple area is our area where they intersect. That's our solution. Homework for this section is on page 399, numbers 7 through 14.